So again, we're just going to be extending the ideas that we talked about last week of factoring quadratics into now solving them. There's kind of three common methods that we'll be looking at. First one is factoring and using the zero product property. This is going to be the big kind of most important method that we'll look at, because this makes use of factoring, which we spent a bunch of time last week talking about, and this idea of a zero product property. We'll also touch on quadratic formula, and if we have time, we'll discuss another method called extracting a square root. This one's the most complicated and is necessary for some problems, but does add some difficulty to things. All right, so we're going to talk about solving quadratic equations by factoring and using the zero product property. Just a quick review of a couple things here. Standard form. So standard form of any quadratic is always written out like this: ax squared bx plus c. When it's an equation, when it is a quadratic equation, it's really important that one side of your equation is equal to 0. So you get rid of everything from one side of your equation and make it 0. And then over here you have your quadratic, right? Remember, what makes it a quadratic is the x squared being your highest exponent power. So this is standard form for a quadratic equation. This side over here is just your standard quadratic standard form, but when it's an equation, it has to equal 0. All right. The zero product property. So this is sort of the key to solving quadratic equations. We'll talk about how it actually works in solving them, but this is the idea. If a times b, a and b are any numbers, if a times b is equal to 0, this can only be true if a equals 0 or b equals 0 or both are equal to 0. If these numbers are not 0, if one or both of these numbers are not 0, it's impossible for them to multiply and get 0, right? There's no two non-zero numbers that will multiply to get 0. And this is really useful. This actually translates into, if you have a factored form quadratic, so if you have your factored form, whatever, I'm just making something up over here. If you have your quadratic in factored form and it equals 0, this equation right here will only be true if this factor or this factor equals 0. And this is how we're going to use it to solve quadratics in factored form. We'll talk more about this in just a second, but if you get your quadratic in factored form, you can use this concept to actually solve it. This equation, again, will only be true if either factor or both factors happen to equal 0. And yeah, how does this work? Let's take a look at it. Well, here is our factored form. I actually made a really similar factored form on the last one, but anyway. So here's our factored form. We can think about this as our a times b. This will only be true if either my a factor equals 0 or my b factor equals 0. So you can write these two equations. You can take your factors right here and you can set them equal to 0. And by solving these equations, you find your solutions. And we're going to have two solutions, one for each factor. So there we go. Here's our solutions. We'll go ahead and solve this first one over here on the left. It's a pretty easy equation. I just need to subtract 3. I get 2x equals -3, and then divide by 2. I could get a decimal or I could leave it as a fraction. I'm going to just leave it as a fraction, as -3 over 2. So that would be one of my solutions to this quadratic equation. And then I can solve the other one as well and get my second solution. This one's actually much easier. I just add 7 to both sides and I get x equals 7. So anyway, this quadratic has two solutions. It has x equals -3 over 2 and x equals 7. In general, our quadratics are going to have two solutions. In general, polynomials with a degree of n, whatever the degree is, this is our highest exponent, they're going to have n solutions. So whatever your degree is, that's how many solutions your equation is going to have. So if this is degree 2, which is quadratics that we're talking about, we're going to have 2 solutions. The higher you go up, the more solutions that you can have. Now, technically, this is what should say up to n solutions, because you can technically have the same solution show up multiple times. If your factors were the same, then you would just get the same solution twice. So technically, that's only one solution. It just showed up twice. But most of the time in quadratics, we're going to have 2 solutions. So, all right, let's go ahead and let's talk about actually doing this as a process. So what does it mean to solve by factoring and using the zero product property? So here we have an equation, right? It's definitely an equation. There's an equal sign in it, so I know I'm dealing with an equation. It is a quadratic, and I know it's a quadratic, again, because of this exponent. That's my highest exponent here. When you're solving a quadratic, you need to make sure it's in standard form. It needs to be ax squared plus bx plus c equals 0. We have a bit of an issue with this one. It's not in standard form right now. It doesn't say equals 0, and there's no plus c. We need to take this 40, and we need to kind of move it over to the other side and make that right side 0. That would be sort of the easiest thing for us to do here. So to get this in standard form, which should always be your first step when you're trying to solve a quadratic equation, I need to simply subtract 40 on both sides. So I'll just subtract 40. I don't have any like terms to subtract it on from this side, but I'm just going to subtract 40. Right, that's going to give me the 0 that I desire on the right-hand side. I'm going to get 0. But now over here, what's left? What's my quadratic look like? It's x squared, nothing changed that x squared. 3x, nothing changed that plus 3x. And then I'll just put minus 40 over here. I'm subtracting 40 from it. I don't have anything to directly take that 40 away, so I'll just have minus 40 on it. So now we can kind of start the process. Once it's in standard form like this, we can actually move into factoring and using the zero product property. But before we do anything involving factoring, you do want to make sure you get it into standard form, which again is ax squared plus bx plus c equals 0. For an equation, it has to equal 0. That way we can actually use the zero product property. If it doesn't say equal 0, we can't use the zero product property, and that actually messes things up. Anyway, to factor this, we got to use a little X game or some other method that you like to use here. So we need to figure out 2 numbers that multiply to negative 40 and add to 3. So you can go through your factors for negative 40, kind of figure this out. Since the addition is positive, the bigger number is positive, it's going to be negative 1 times 40, negative 2 times 20, negative 4 times 10, negative 5 times 8. I think that's about it. Going through those options, looks like this is the one that's going to give us the right sum. Negative 5 times 8 is negative 40, and when I add them together, I get 3. So negative 5 and 8. That's our solution to this X game. Because this was an easier one, right? This is a leading coefficient of 1 and a equals 1 quadratic. We actually know the factored form already. We don't need to go to the box method at all. We can just write out factored form. It's x minus 5 times x plus 8. Minus 5 because this is negative, plus 8 because this is positive, and factored form equals 0. Right, I just took this quadratic over here and I factored it. So now it's in this factored form. And here's where we start using the zero product property. Once you have it factored and it equals 0, you can split it up into 2 equations. So my first equation, very simple one here, x minus 5 equals 0. I take my factor, I set it equal to 0. This equation will only be true if one or both of these factors equals 0. So I can find my solutions this way. Take my factor equals 0. This one's very easy. I just add 5 to both sides. And I say x equals 5. So that's one of my solutions. Easy. And my second solution, very similar. I take my other factor and I set it equal to 0. So x plus 8 equals 0. Again, a very easy one to solve this time. I subtract 8 on both sides, and I get x equals -8. So those are my two solutions to this original quadratic equation. That's it. I'm done. This one is not too hard, again, because the factoring was a little bit easier. Really, these problems are sort of as difficult as the factoring is. If the factoring is pretty challenging, then it'll take you a little bit longer to solve them. If it takes a lot of work to get it in standard form, that can make it a little bit harder. A lot of different factors here, a lot of different things here that can make this more complicated. But in general, this is the process. We put it in standard form, we factor the quadratic, we take our two factors and set them equal to 0, and that's going to be our solutions. Whatever we get for those, that's the solution. So we'll go ahead and do another one here. Hopefully that all kind of made sense. A lot of the process was something we are probably already familiar with from last week. But. All right, so here's another example. Great thing about this one is it's already in standard form. It's already equal 0. It's in ax squared plus bx plus c. It's already in standard form. Nothing we need to do to set it up. We just can go straight into factoring. This one will be a little bit more challenging to factor because it's an a greater than 1. Our leading coefficient is greater than 1. So we do need to do something else in the factoring process. Whether you use the X in box or whatever method you use, the factoring will be a little bit more complicated in this case because of the number here. Again, I'm going to just do it with the X game and the box method, but if you have another way, that's fine. Whatever method works for you. Yeah, this is the way I'm going to do this one. So to use the X game in this case, we got to do 2 times -8. That's what's going to go on top. So it's -16. And then 15 goes on the bottom. So we're looking for two numbers that multiply to -16 and add to be 15. You can go through your options here, but it's going to be 16 and -1. Those are the two numbers that multiply to be -16 and then add to be 15. When your addition number is really close, like just one off of this, you know it's going to be 1 and that number. You just have to figure out which one's negative to sort of make it work. If it's just one more or one less, you know, it's just going to be 1 in the number. You have to just mess with positives and stuff, positives and negatives and stuff. So the reason we do the X game really is to split the middle term. So instead of having 15x, we're actually having 16x and -1. 16x and -1x. That allows us to have 4 things to go in our factoring box. So it's 2x squared, 16x, -1x, and -8. Those are the 4 things that go in our area model or our factoring box. And then, well, we need to factor. We need to figure out the binomials. So again, this is a little longer because we had to do this extra factoring step, but I just want to start in one of my rows or columns and find a GCF. So right now I'm just looking at this row and I'm looking for my greatest common factor. Well, 2 is the greatest common factor between 2 and 16. And both of these terms have an x in common. So I'm going to have 2x right there. And then from there, I can keep using GCF, or I can kind of use the box to help me out. It just whatever works for you. I'm just going to keep using GCF personally. These are both negatives, so they have a negative in common. And then 1 and 8 only have a common factor of 1. So here is my first binomial, 2x minus 1, over here on the side. I need to figure out the other one. I need to figure out the top as well. So now, again, I can use the columns, find GCF in my columns, or I can use the boxes. Totally up to you. Looking at this column, they have a greatest common factor of x, and that's it. They have a factor of 1 also, but I'm just going to write it as x rather than 1x. And then here in this column, they have a common factor of 8. The great thing about the box, the reason I like the box is it is sort of self-checking. You can kind of go back through and make sure everything multiplies correctly, right? You can check it out. 2x times 8 is 16x. Negative 1 times 8 is negative 8, right? You can just always check these multiplications to know you did factor it right. So that's my second binomial now here on top, x plus 8. And so now it's in factored form. And we would use the zero product property to finish this off. We take our two factors and set them equal to 0. 2x minus 1 equals 0. I think you're maybe talking about right here, the question was asked of why this is not squared. And that's because when I look at this row, this one has x squared, which means there's two x's here. There's an x and an x multiplied together. But this one only has a single x. So they don't have x squared in common. So I don't have an x squared here. They only have a single x in common because this one's not squared over here. So that's why that's not squared. The way I get x squared in my multiplication is through multiplying these terms together, right? This x squared comes from 2x times x. That's where I get the x squared. The two x's getting multiplied together. And in our binomial factors, we never have x squareds in those. At least in factoring quadratics, we don't. Yeah. So anyway, I take my first factor, set it equal to 0, and I solve that. So this one's a little more complicated, but still a pretty easy equation. I'll add 1 to both sides and get 2x equals 1, and then divide by 2. In general, I like to keep my answers exact, but if you wrote this as a decimal, it wouldn't be that big of a deal. I mean, 1/2 or x equals 0.5, whatever, it doesn't really matter. If your decimal is a non-terminating decimal, if you end up with like 1/3, and then you write your answer as 0.3, these are not the same thing. So should technically be 0.3 repeating, but in this case, it's really better just to write the exact value of like 1/3. Anyway, it doesn't matter for this problem because both of these are exact. 1/2 or 0.5, doesn't matter. I'm going to leave it as a fraction though. Then the last one, we got to take this factor here, set this one equal to 0 also. This one's much easier. All I have to do is subtract 8 and get x equals -8. Anyway, those are the two solutions, and we're done. You can always check these. You could take our solutions and plug them back in and make sure it does actually work out. Not too difficult to do if you had like a calculator or something, just plug in the numbers and go. Yeah. All right, we're going to take a look at one more of these, just one more. And then I'll see if there's any other questions. So here we have this. This one looks pretty messy. It's not in standard form. Just throwing that out there, just looking at it right now, it's not standard form. So I want to make one side 0 to sort of get us towards standard form. So the easiest thing would just be to get rid of this, to subtract 2x on both sides. So, or sorry, 2x squared on both sides, right? So that's what I'm going to do. I'm going to get rid of the 2x squared. That cancels out here. I do have another x squared term on this side, so I can actually subtract it directly from this one. I can just get rid of those right there. If I didn't have an x squared term on this side, I would just have to put this -2x squared on this side. But since I do have a term, I can actually take it away from there. So that's going to become 12x squared minus 75 equals 0. Okay, this is not a trinomial as I'm looking at it, right? It's kind of in standard form, except it's missing this b term. It's missing this middle term, right? I don't see it in there. Technically, what's going on is I do have it. There's just a 0. I have 0 x's in this problem, so I do have it in standard form. It's just my b coefficient happens to be 0 in this case. Hopefully, you guys are recognizing this as a possible difference of squares problem. Because now once we've got it in standard form, you know, looking at this kind of looks like this might be difference of squares. It's not yet, but it could be. 12 and 75 are not perfect squares, so I got to do something else first. I got to factor by GCF. So I wanted to throw one of these in there. So I have to find a greatest common factor here. And the only one I can find is 3. Both of these are divisible by 3. Yeah, absolutely. We would use that. The problem with this one, Sasha, is that since these numbers are not perfect squares, it actually makes it a little more complicated. So we're going to first get rid of a common factor that everything has, and then use that exact pattern that you're talking about. So I'm dividing everything by 3. I'm allowed to do that. I'm allowed to divide both sides of my equation by 3, right? That doesn't really change anything. So if I divide everything by 3, I get 4x squared minus 25 equals 0. Now, hopefully it looks a little better. Now, as I'm looking at this, these are all perfect square numbers, right? 4 is a perfect square. 4 is 2 squared. 25 is a perfect square number. That's 5 squared. And at this point, I should be able to use my difference of squares factoring. So remember, difference of squares looks like this. A squared minus b squared factors into a minus b times a plus b. This is what we're talking about. So this one here, yeah, perfect. So I'm seeing the answers in the chat. This is going to be 2x squared, and this is 5 squared. So that's our a and our b. So when we go to factor this, it's going to be 2x minus 5 times 2x plus 5. This is perhaps not the easiest way to solve this problem. There is an alternative way of going about this. But since we're talking about factoring, I wanted to go through it this way. You'll notice the only difference here between our two factors is the plus and minus, because again, this is our conjugate pair or difference of squares factoring. But we still apply the zero product property. We set both of these factors equal to 0, and we'll get our two solutions. And because the only difference is this plus and minus, we're actually going to kind of get the same number, but one of them is going to be positive and one of them is going to be negative. So when I solve this one, I have to add 5 to both sides. I get 2x equals 5, and then I divide by 2, and I get x equals 5 over 2, or 2.5 if you prefer that. And over here, the only difference is I have to subtract instead of add. So I'm going to get a negative number instead of a positive number. And then divide by 2 again, I get negative 5 over 2. So very similar solution, just one's positive, one's negative, but really kind of the same number. And there we go, that's it. These quadratic problems can come in sort of any form that we know how to factor. So they can come in this difference of squares pattern. They can come as trinomials. They could even come as higher degree polynomials. So even if we had something like this, even if we had something like this, it doesn't look like a quadratic because it has x cubed. But you can see we can factor away an x from each of these terms. And then what we would be left with would be a quadratic, and we could kind of keep applying our strategies there. So they can kind of, these problems can come in sort of any form that we're already familiar with. Yeah. All right, I'm gonna go ahead and stop this part right here. We have about 3 minutes left.